This is the Amp Hour Podcast. Released February 20th, 2022. Episode 578. Histogrammic or Histomagraphical?
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
I think I'm officially in Hollywood now, Dave. I have a sandbag holding down. I bought these sandbags like probably 2 years ago, like the actual thing to hold sand. So they could hold down stands like my microphone stand. And this last weekend, I finally went and bought some rocks, and I put some rocks in today. And I have a cantilevered microphone stand, so I am in the big leagues now.
Because before this show, we were just talking about renovation stuff, and I'm thinking, what? He's getting into sandbags and what? Okay, right. So you've got a little sandbag that
hold down a microphone stand.
Yep, right.
Yeah.
Got it.
Pretty much a professional photographer.
Well, yeah. What? So you did it yourself without buying like a fancy, audio full bag for like $200 or something, right? That makes
you don't need to. Yeah, apparently you can just buy like reinforced like canvas bags.
Right.
And they actually have little like caution labels on them, so you don't kick them. And they're great. So now it's just a bag of rocks.
Labels. Yeah.
Just a big bag of rocks. That's all it takes. Innovation.
Did you actually pay for the rocks, or did you just go and
I did have
them?
to pay for the rocks. Yeah. Oh. Yeah. The rocks that I have are currently being used as a path. So I wanted to keep them in that employ.
Got it.
Because I could have found a neighbor that had some rocks in their paths, but no.
Well, the audio is certainly sounding more solid.
Yeah. It's like really.
Are you still using that Linux rubbish that we
Linux
got
box.
pop last week?
I think it was actually it was not the driver. It was the hard drive that was plugged into the same USB port next to it.
Okay.
So I think the traffic might have been a little. I don't know how that works.
Actually. Yeah, because that is not an audio. Like that is like you'll get that if you've got an analog system. Like current pulses from the drive will be
like the noise from a switching converter or something.
No,
like that.
This is not it. This is digital dropouts caused by there's just so much bandwidth being chewed by the hard drive, right?
That's right. Yeah. Packet loss. I kind of think about it.
Yeah.
I may be wrong about that, but
I think the terminology is wrong because you don't. Well, no, actually, in streaming audio, that might be right.
Yeah.
So yeah.
I'm still signed up to get a Luna, which is a thing that Great Scott Gadgets is making, and it's a Kickstarter that is on the way. In theory, all things come with an asterisk these days.
And what is a Luna?
Luna is the brainchild of Kate Temkin, and now being made by Great Scott's Gadgets. It's like a USB analyzer, like a low cost.
Oh, I saw it. Yeah. I think we've talked about this before. Yep.
I think so.
Yep.
Yeah. So
all right.
That's still on the way. I think I'd be able to look at the packets though.
No, it's a USB protocol analyzer. Yeah, I've got one. Right. It's one of those expensive ones. A company sent it in for mailbag, and
oh, interesting.
Basically, It's one of those things. As if you need it, you need it. It's like
that's right. Yeah. What is the price? All right, I'll pay
it. Yeah, right. Yeah, exactly. You'll pay anything because you're actually developing. Yep. So,
and I think I'm actually I just got an ESP32 S2, which has a native USB driver in it.
Hang on. You physically got an oh no, this is ESP. I was thinking you physically got an STM32. How is that?
Oh God, no. Oh no.
What'd you do? Pay $1,000 for it?
Yeah. No. Yeah.
Right. ESP.
No, this is ESP32 S2. And actually it's so I have one of the breakout boards just from Espresso. It actually runs CircuitPython as well. And so really fast prototyping and stuff like that. But the cool thing about it is you don't need ESP or USB to UART converter anymore, which is nice.
Right.
It actually is just built in. So yeah, lots of fun stuff coming out from Espresso too. I think they have
but boo-hoo. I want serial.
Oh, you can still access the serial port. I mean, you'll need so like there is a USB to serial internally.
Oh,
right?
okay.
So you can
got it. There you go. All right.
Fun parts.
Mm. This, like on the Reddit this week, it's all about bloody ASICs and fabs and ASICs and fabs and ASICs and fabs and ASICs and
Yep.
fabs. What the?
Yes.
Oh, do we have
Yeah.
to
I mean,
talk
some of
about
this I don't
ASICs
think
and
we
fabs?
talked about last time, but I was actually, you know, a bit cynical, but also a bit excited. TI is building new fabs. That's great. They
Yep.
had previously kind of outsourced some of their production. They still had some of it in the US, but they also, use TSMC like everybody else. I think this is just kind of everybody, like we talked about last week, everybody trying to get some of that US money.
Yeah,
Fine,
right.
cool,
Oh, yes,
whatever.
the Uncle Sam money.
That's
Yep.
right. But I think
Right.
also just spreading it out a little bit more. It'll be interesting,
Mhm.
like 5, 10 years from now, are we going to be seeing news items of like, well, actually, we feel like capital expenses are too high and we're going to outsource it again to, you know, a foundry.
You're
I don't
right.
know. We'll see how long the memory of this lasts, and if we're willing to keep investing.
Right. So are TI borrowing the money for this? Is it a gamble, or do they just have so much? They're sitting on a throne of cash that they want to, spend.
I think anyone who's not financing this right now would be an idiot. It's basically free money right now.
Right.
But this is all, this is going to be
Yep.
it's this through 2030, right? So like
Right. Got it.
this is in theory a longer play.
Well, yes, they say it's expected to generate 5 to 6 billion in revenue annually for the company once it's fully operational. So,
Yeah. Yep.
yep. Hmm.
Yeah. I think it's just upgrading their fabs too. Like I think they still have some 200 millimeter plants, but they're going to switch it to 300 millimeter. Interesting that you still don't see stuff going past that. The 450 is just not really a
Right.
thing.
It wasn't a thing. Didn't turn out to be a thing.
Yeah. Some of it is just like the process stability across a wafer that big is really
I
tough.
was I was going to say, yeah, there has to become a point where the orthography stuff and the physical, you know, uh, manufacturing of the ingot and everything else, and like sawing wafers that thin and wide, like it's
Yeah,
got to
there's
reach a
some of it's
point
that,
where
yeah.
it's
Yeah.
yeah,
Yeah, I think of also like I mean, so my old gig in dry edge, like some of it was just like trying to get like a uniform, basically like a cloud of plasma across the whole thing is really
yeah,
tough,
right,
right? That's like part
yep,
of even on a 300 millimeter it's tough, and
yeah,
they play all these different tricks to do that sort of thing. So just trying to get that process
mm,
conformity is really difficult, and I think that's part of the reason. But I think all some of the stuff you said as well, and maybe the efficiency gains aren't as much as they need for the
yeah,
the cost benefit.
yep.
So
And then you would need all new equipment to physically
that's right.
handle and
Yes, that's right.
probe fabs that big, and then your test jigs get more.
Yeah,
Everything
the
just
robots that
gets
carry things. Yeah, yeah.
everything,
Even
right? Yeah,
carrying a container
storage
would be
bins
tough.
and stuff like that.
Yeah, that's a good
There was
point.
this
Yeah,
fascinating thing on Twitter, which I retweeted. Why were all computers 80 columns? Why were they 80 columns of text? Why is it still 80 columns of text is the de facto standard? And
huh?
if you get like, yeah, so this Twitter thread that I put down, we'll try and link it in. I can't remember who it is, but they go through the chronological history or the reverse chronological history of 80 columns and where it goes back to. And if you go back far enough, it goes back like 500 years or something. Like it's
Really?
crazy. But at one point, this is why
I,
this
di-
is
I
why
didn't I didn't know about the computer back then.
but yeah, so but it eventually makes its way back to punch cards because IBM in 1912 or something made 80 column punch cards, right? But the thing that reminded me of this is that those punch cards, the reason that they were 80 columns is because that's what they could reliably fit onto that width of card. But why did
Huh.
they use that width of card? It's because they had to fit into the existing postal bins that I think the
Oh,
postal
that's
service or
interesting.
something used because they didn't want to upgrade all their storage bins, so they wanted them to be the
Yeah.
same width. So that's the width they
Yeah.
made the things, and it's like the old why are train tracks the exact width they are because it comes from a horse's ass, right back in the Roman chariot days because it's actually two horses' asses wide or something, and then that's how they and the ruts that the carriages used to go in, they were two horses' asses wide, and that's how our train lines became that wide as well. It just carried through the century,
Wow.
and it's a similar thing with the
See,
80
that's why you
column
got
thing.
you got to
It's
you got
like
to think about this before you go and decide that you're just going to use 2 horses? Were you thinking about the downstream effects of how it's going to
Right,
impact trains and their
in
efficiency?
500 years old? Yeah, these
Yeah,
what
come on.
what if they made these mechanical horses in 500 years' time? That,
Right, some kind of horsepower.
Yeah.
Yeah.
But anyway, I thought that was absolutely fascinating. Yeah,
Yeah,
it's
that's
because
great.
they chose that width because of the physicals, just the storage bins they were using, and
Wow.
and at the fabs it'd be the same, like the physical bins and storage and handling systems. They're all
Yeah,
designed
yeah.
for like yeah.
Yeah, and human
So
dimensions as well, right? I mean, like some of
yeah,
it's
yeah, yeah, of course.
yeah there.
Yep.
That
Yeah.
is interesting segue. I've been searching for new books, and I found a new book, and it's been pretty good. It's called Dealers of Lightning. I may have heard about it from Dealers of Lightning, Xerox PARC, and the Dawn of the Computer Age. And so it's all
Nice.
about
Yep.
that time frame. So like late 60s through the
Uh-huh.
70s into the 80s, basically the heyday of PARC,
Yep.
all of the UI, but just generally, I mean, like I really didn't, I still don't know. I'm only a couple of chapters in, but it's really interesting just kind of that mainframe day, moving from the mainframes and the time sharing into the individual, personal computer days. It's a
Right.
very interesting history. A lot of names I don't know either, but I probably should. Like a lot of people are probably screaming at their podcast player right now, like, you should know all this stuff.
You should know
But
Douglas Engelbart.
I should, right? Yeah.
Yeah, no, it's
Yeah.
like he did the mother of all demos.
What is that?
Oh God, come on. Wash your mouth out. Douglas Engelbart. He did in the 19 when was the mother of all demos? 1968. 19 Here we go. I'll give you hang on. 1968.
Is this a video demo? This is like I may have read about this and I've just forgotten. I'm also
It's
reading it
a
before I go to
yes,
bed, and
it's
so
a
I often
video demo.
forget
Yeah.
stuff.
It's
Okay, yeah.
it's in 1968, right? And
Okay.
he demoed everything, pretty much everything we had today. He demoed video conferencing,
Oh, I did read about this.
networking,
Yep.
the
Yep.
mouse, graphical user interfaces,
Yep.
hypertext language,
Mhm.
hypertext types, some sort of markup language. This was all demoed in 1968.
Right, but this actually, I don't think that was at Park. I think he got hired into Park.
He
Isn't that
did, I
right?
think, something like that. Yeah, this was at another think tank. This was at another
Yeah,
government
I think this is
think tank.
at Berkeley Computer Company or
Yeah,
something, right?
something like that.
Berkeley.
Yeah,
Is he one of them?
the Augmentation Research Center
No, that's not
at
him. Okay.
SRI.
That's all right. Okay, cool.
Yep,
Yep.
SRI, which is the Stanford Research Institute. Yep.
Right.
Right.
Actually, our guest last week used to work there as well.
Oh,
So
there you go.
Michael Core was a
Right.
engineer there at
Yep.
one point.
Anyway,
Mother of all demos. Huh.
yeah, mother of all demos, dude. Watch it.
Engelbart's law, the
There's
observation
actually
that
video of
intrinsic
it.
rate
There's
of human.
full. Yeah.
Yeah. Okay. All right.
Yeah.
Yeah. That's the
It's
thing. I got to learn about this some point.
yeah.
Like, how did you learn about this guy? I don't know. Like,
Because I was because I'm into computer history. I was really into it like 20 years ago, and I read all the all the books on the history of Park and all the early.
wait.
What
Are you going to have a book recommendation now, Dave?
would you like me to have a book recommendation?
I would love to have a book recommendation. Usually you go, Psh, books. But like this is, I mean, like, so it is a very interesting period in history. I'm comparing it mostly. So first off, I do not love the writing in this book. It's like super wordy and like needlessly so. Like the guy's trying to prove himself with like
Oh,
big
okay,
words, like,
right.
dollar words when a 10-cent word would do kind of thing.
Okay, yeah, right. Yep.
I'm getting through it. It's fine. But it's just like, all right, tone it down a little bit, Michael. But the content is great. I'm comparing it to the book that Jeff Kaiser had recommended to me.
Mhm.
The what is it called? The one about Bell Labs, the Bell Labs book that we've talked about many
Right.
times on here. So
Okay.
if you don't remember it, go and listen to all of Amp Hour.
All right.
and you'll hear me talk about it a bunch.
I'll give you a book recommendation.
All right.
Hackers, Heroes of the Computer Revolution by Stephen Levy.
Oh,
Came
okay.
out in 1984. Jeez. Okay, I read it in probably 91, maybe, something like that.
Okay. Yeah,
I
yeah.
don't think I read it. Yeah, Hackers, Heroes of the Computer Revolution, Stephen Levy. So if you want,
Okay.
yeah, that
All right. Yeah.
gets a lot of
That'll
the
be. I'll
early
put that on my list.
the hacker culture, the hacker ethic at
Yeah.
MIT and stuff like that. It's
Yeah,
about
yeah.
how
They're
they
talking,
all,
I mean, they keep talking about
Yep.
the engineer's engineer, and as they talk about that, one of the hardware guys they're talking about, and how like all of the ROM was built with diodes, and so they actually when they were reprogramming the OS, they had to like desolder diodes, and it's just like, oh my god. So yeah, I would not have made it in those days, Dave. I'm barely making it these days, but
right. Okay. So yeah, these are the days of Lee Felsenstein and others. Is he still around? Lee Felsenstein. He was he did the Sol computer. This is the days of the early homebrew computer club that Steve Wozniak went to the first thing of the first meeting of the.
Yep.
Yeah. Famous home.
Yeah, I think the part of the book
and then
is still
everything
before that,
stemmed
though.
out of that. Oh yeah, no, there's no, that was like in the mid to late 70s, the homebrew computer club. But there's history before that. Yeah, it's absolutely fascinating.
Yeah, so I'm like where they're like moving from the SDS 938 to the SDS 940. That's like the big mainframes that they were building and stuff like that. It's just.
Yep.
Yeah, looking at some of these photos, they're just insane.
Oh,
these are like the room
it's got
computers,
photos as well. Okay, right.
Yeah.
Nice.
Yeah.
Yep.
So lots of history there. Yeah. Yep. So like I said, very interesting period in history. I had never really done it. Definitely some personalities, but not as strong of person. And that's the thing I was thinking about with the Bell Labs book. Is not as strong as personalities because like Schottky and Bardeen and like they're just like, and I forget the manager there that was at Bell Labs that is famous. Like all of the, they just the big historic names. I just don't know them from history class, basically, or physics history class, I guess. Well, so it's just kind of like in a different era,
Yeah, well, a ton of them, like probably the vast majority, almost all of them, of the early names in the computer business and all that sort of stuff, they're all just like lonesome nerds, right? They're all just like, they didn't, they weren't Steve Jobs like,
Yeah.
It was,
It does sound like there's a lot of, like that was the lonesome surprises me because it doesn't seem like they could possibly do much on their own. Like it's just such a big system.
But they were either hanging out at the lab or something like that, and they would go to these homebrew computer meetings, but they weren't, media personalities. Like they didn't, they weren't, they were sort of like known in their little tiny inner circle, and that was kind of it. But
got it.
Yeah.
Yeah, I mean, I guess if they didn't hit it big either, right? They
no. Yep. Unfortunately, a lot of them. Like, oh god, I can't believe I forgot his name. That sold the rights to MS that became DOS for like $80,000 or something. So, and that what made, Anyway, yes, I can't believe.
How would you know in the time? Like how would you be able to tell?
You don't, of course.
I will say obviously I'm reading about this stuff now. If people are listening and they're like, there's this pioneer of computing history that's still around, interested in talking to people, would love to talk to them. Yeah. This is not. We've had Bill Hurd on the show. Bill's a little bit later in this process.
Oh yeah, yep.
Who did Bill introduce us to?
He's still a young whippersnapper, Bill Hurd.
Yeah.
Unfortunately, no more Douglas Engelbart. He's not still around. Lee Felsenstein, I'm looking at. Oh, he's currently 76.
Yep. And that's the other thing. So like I was telling Dave about this the other day. We were chatting and like I was like, oh yeah, I'm reading this new book. I'm really excited. We should like try and talk to people. I was like, oh yeah, this is like 45 plus years ago when they were
most of the people are dead. Yeah,
they were in their 20s and 30s. I'm like, yeah, this is like they're all retired. Like they're very certainly maybe not all retired, but like they're getting on in their careers. They're probably at retirement or should be retiring. Like sort of thing. So at least relaxing and doing electronics for funsies. That's what I'd hope.
Right. Well, what's the official retirement age in America?
There isn't really like an official one, but it's usually pegged to like when Social Security kicks in. Okay. And so the three ages are 62, 65, 70. Okay. And so you get different amounts of the pension, effective pension, depending when you decide when you file for retirement.
Got it.
More is later. So, yeah. But I will be going to the Computer History Museum finally.
Excellent.
In June.
Woo-hoo.
Yes, I'm very excited about that.
Yep.
If all goes well, I will be there. Health wise and such. Maybe I'll be learning more about this stuff.
Yep.
Maybe I'll run into some of the big names just mulling around. I'm sure they
just hang around there all the time. Yeah. I made it, as the kids come in. I built this. And the kids
I mean, it
run
happened
away.
at the train
Mummy, that
museum,
man,
Dave. Why
mummy,
not at
yeah, I
why
know.
not at the history museum, the computer
Mummy,
history
that
museum?
man's scary. He's trying to tell me about computers.
But I just like bring a microphone and just like look for someone who's a little bit older, and I'm just
Yeah,
like,
right.
so
And just,
what did you invent on the computer?
yep, yep. Yeah, I can remember
Yeah.
going there. It was great. Yeah, I walked. I took the train, and then I walked like, I don't know, because it's in the US. I walked like 5 miles or something to get there.
Yeah.
I remember,
Yeah.
screw taking the bus. This is too hard. I'll just walk. So
Yeah.
I just walked to the Computer History Museum. Anyway, very cool.
Yeah. Yeah. I don't think the train drops you off for too close. So.
Right. Computer history. Good stuff.
Well, I'll have more to report later as I read more of this book and as I visit the museum.
Excellent. Well done.
I will also be. I will remind people I'm supposed to be going to Embedded World. Assuming that happens, it'll be in Nuremberg, Germany, in the 3rd week of June. So if you're going to be there, give me a shout. That got rescheduled for March.
This is a corporate junket, obviously.
Yeah, this is a big one. This is like a mini electronica, basically embedded focus. So yeah, I'll be at that and ready to mingle.
You'll be so you'll be on the stand, will you? You'll be manning the stand.
Probably, yeah. At least part of the time, I'll be around a stand.
Cool. So. Well, no, it's not, because anyone who's been on a stand knows how.
Yeah, it's tough.
Yeah, painful it is.
Comfy shoes and a lot of hand sanitizer.
Yep. And eat, otherwise you'll like just faint or something because you've been standing up all day, and it's
it's never been a problem for me in the past, Dave.
Yeah. Right. Okay.
I like eating quite a bit. So
I don't know. I thought you were looking pretty skinny these days. Well,
yeah, I mean, I walk a lot now, but
right. Okay.
I eat a lot too, so doing fine in the energy realm.
Got it. Speaking of standing up, I'm contemplating getting one of those newfangled stand-up desks.
Yeah. You're right at the bleeding edge of.
Yeah, right. I'm about 20 years behind.
Of the trend. Yeah.
Yeah. I don't know.
Now, is this just for the computer desk or for the bench as well?
Oh no, this is just for the computer.
Got it.
Thing. So, of course, I asked Twitter if
Of course.
And the poll was that only, I think, about 10%. I have to link it in. Only about 10% of people actually said, "Oh yeah, it was completely life-changing. I use the stand-up desk all day." The majority of people said, "Oh yeah, it's okay, but you wouldn't use it all day. Like you wouldn't stand up all day."
Yeah.
So if you are going to get one, you get one of the hydraulic preset ones, so that you can just go, "Oh, I'd rather stand up for an hour or two." So you hit the button and the whole thing just raises up to his preset height, and Bob's your uncle.
Yeah, I mean, there's another thing you could do. So I am currently sitting in a drafting chair, so it's higher up off the ground, and so basically I have my desk set at a standing desk height. My chair is much taller. When I'm ready to stand, I get off the chair.
Right.
That's another way to do it.
Oh, right. Okay.
It's a little less sturdy, to be honest. I mean, it's not as useful that way, but yeah.
Yep. So yeah, maybe I'll give it a try. I don't know. See what happens.
Yeah, I mean, why not? I would recommend if you do get one. I have you've seen my manual benches that have like a crank on them.
Yeah, I don't.
The crank does not happen that often. I had a motorized one at my workspace at MHub, and that I got into using more. So.
Yes, I know. I definitely get the motorized one because you don't want to dick around, because you set it properly, right, and then you preset the height, so it's perfect. So all you got to do is push the button, wait, 10 seconds, and it goes up, and it's the perfect height. You don't have to dick around. You don't have to, don't have to do.
That's a fancier one than I had. Mine was just up down.
Right. No. Yeah. I want. Everyone recommends ones with the presets. So
cool. Yeah. Okay.
Cool.
Yeah. I mean, that's interesting.
Yep. Oh, going back to books for a minute.
Oh.
Wow. Once again,
going back to books for a minute.
Going back to books for a minute. I was going through my bunker the other day, and I found my counterfeit copy of the Bible.
Oh.
And it was. I posted some photos of it on Twitter, and all the pages of I don't know if it was like that when I got it. I'd have to maybe search for some. I was going to do a video on it when I got it, but I never got around to it. Because they sent me a counterfeit copy and a real copy right? So I could see the difference. And all the pages have like turned yellow, and like the edges of the page, they're all just like all these multicolored, almost like rainbow colored pages in this counterfeit copy. Oh my goodness. Yeah. So,
what is the recommendation here? Is the recommendation to buy a counterfeit copy of The Art of Electronics? Because I don't think we should recommend that.
That is not the recommendation. No, it's it does not last. If you buy a counterfeit copy, I suspect it may not be.
How did you know it was counterfeit? It actually looks. So this is the 3rd edition too.
Yes, it's the 3rd edition. You can tell. Because when they sent it to me, it had counterfeit on it. But you can tell, like the pages just like the pages aren't neatly aligned. The paper's thinner and cheaper and crappier. It just makes you screen like
Is it counterfeit or like I've seen like
yes, it's actually
low cost editions.
No, that is not. It's not an official low cost edition. It is a completely ripped off version. Yep.
Interesting.
And and it just uses like variable quality paper. Like that's why you can see it all different colors. Like the paper's just like they used whatever paper they could get and they shoved into this thing, and it's like multiple different types of paper, and they've all just like faded and colored differently, and you can tell like some pages aren't neatly aligned. They're like slightly askew, and the print quality's not as good, and you can really tell. So yeah. So there you go. Don't buy a counterfeit copy. The Art of Electronics is no good. They're garbage. So,
yeah. Okay.
All right. What else we got?
I was waiting for a new book recommendation. I guess I'll have to wait. I'll wait a little longer.
I already gave you a book recommendation.
You said another recommendation. Okay, anyways. Yeah,
no. I always said we're going back to books. I didn't say I was going to give you another recommendation.
Good point.
I'll give you one recommendation a week. How's that?
That's fair. Yeah, I'll take it.
All right.
Mark it.
Okay.
All right.
All right.
Speaking of bum deals.
Okay.
ARM apparently is not going to Xilinx or not going to NVIDIA.
We predicted this, didn't we? We thought it wouldn't happen because there was a good chance. I think we were erring on the side of, it may not happen.
Yeah.
Let's just call it that we predicted that wasn't going to happen because, for those who don't know, there was too much regulatory issue because companies, there's so many companies that use ARM, which are competitors to them. So if they own ARM, then they can technically get access to their competitors' IP, right? And it's like,
probably not directly IP. Yeah, I wouldn't think directly.
But like it was.
But they could definitely influence. They could unfairly.
They could unfairly. Oh, sorry, the fab's a bit busy this week. We're going to have to delay your production a week and another week. Sorry about that. Oh, oops, a machine broke down this week. Oh, we won't be able to deliver those. Oh, you wanted your new iPhone.
That would be the
phone,
foundry. That would be the foundry who's saying that. This would be more like we're delivering, the ARM H5500 or whatever new crazy name they have for a thing.
Right.
But for you, it's going to be a little bit more expensive.
Yeah. Oh, you've got a bug in that thing. Oh, yeah, we'll work on it.
Right.
Yeah, right.
Yeah. So I don't know, but they're gonna IPO instead. Yep. I guess whatever. I don't know.
Who cares?
ARM is in weird places right now. This is so they were bought by if people don't remember, they were bought by Softbank.
Yep.
A long time ago, and not a long time ago.
Hang on. If they're going to do an IPO, that means they're a public company.
That's right.
They better be careful how many shares they release. Otherwise, in theory, couldn't they just come along and buy every share?
That's right. Well, I think normally in that case, the price would go up so much that it wouldn't be worthwhile because as they start, they wouldn't be able to buy enough at once to be able to become a majority shareholder.
If you offer enough, people will sell.
Right. But that's the idea, is that it might not be worth. It'll be probably priced in.
Okay, yeah, but then you're relying on the market to control the sale, and
sure, yeah. I think there's still ways that they could exert influence in that way, no doubt about that.
Right.
But I didn't really care about this purchase myself.
Yeah, no, I didn't care either. No, zero.
Yeah, this is many steps above my head. So I don't know, until it's.
By the way, we missed a segue. We missed it. We're talking about the art of electronics, and we missed the segue, dude. We need to hand back our professional podcasting credentials. I mean,
I still don't know what you're talking about here.
Sorry. It's in the Reddit list. It's in the Reddit list. Look, where is it? It's number. I don't know. It's about ninth down.
That's right. The community contributed solutions.
Community contributed solutions to the art of electronics. If you don't know, the book there's a companion student thing for it.
Yeah, this is actually for there's also problems throughout the text as well.
Yes, there is.
So I think this set of solutions is for the problems in the text because there's no solutions guide.
Oh, okay.
So
right.
if you wanted to go and check your work, you wouldn't be able to.
Got it.
Yeah.
Okay. So
yeah, if people are listening and they want to contribute and you like playing around with LaTeX and laying out out formulas,
which is a kind of like is it a markup language? Is that the correct?
I think that's right. Yeah. Markdown, markup. Yeah.
And you call it LaTeX? It's LaTeX.
I thought it was LaTeX. To the wiki we go.
This is quality radio.
Yeah. Yeah, I don't really care what it's. You know me. I don't really care how it's pronounced, but I'm.
Yeah.
LaTeX, or LaTeX.
LaTeX.
Yeah. I don't think the X is actually an X.
Oh, really? Okay.
Yeah.
Jeez. All right.
Yeah.
Yep. Anyway, it's like a markup-y kind of language. You can do like formulas and everything with it. It's kind of Yep.
Yeah, I think people in the academic world are very used to it. You've written papers before, that sort of thing. And it's better than I actually remember physics class not having access to this sort of thing, and then trying to go into Microsoft Word and
I know.
Well, actually no, this is a square root, so I have to find a square root symbol.
And drag it in, and you do it manually.
Second power, and yikes, what a mess. Yeah. So from that, I get it. I get it. That's fine.
Totally.
But not something I'm using on a regular basis.
Anyway, cool. So this is a GitHub-y type thing, so you can add to
Yeah, you could submit a pull request. You could, submit an issue against it. Say, this is right, this is wrong, whatever. I worked out this problem.
Yep.
Have discussions around it, that sort of thing.
So does it tell you? Does it give credit for each person who solved each little bit and wrote up each bit? It doesn't seem to. I'm having to look through it now.
Just care about the credit, huh, Dave?
Well, no, but who? Well, in which case you don't know who's authoring what, right? So it'd just be.
Well, you do from the revision history, right? So you'd have that. You could see who submitted it.
Yeah, but no, I think it'd be nice if everyone put their name next to the solution.
What if you have 15 people working on a problem together?
Okay, fine. Oh yeah, but come on, no, these things are always one person. Come on. These things are never multiple people. As if you're going to have a team of people working on one problem, one Ohm's law problem in the art of electronics. And let's form a team and we're going to solve this and then we're going to publish it together and we're going to fight over whose name goes first on the publish. No. It comes down to one person.
I mean, if Bill and Dave are working on a problem and they work on problem 1.11 and Bill does all the work on it, but Dave corrects his, LaTeX syntax, do they both get credit on there? I think it's easier to just leave it off, in that case.
Yeah, but if somebody went to all the effort to format it and write it and do it, their name would go there, and then you'd have to go, and then you'd add a corrected by, Joe Bloggs kind of thing.
I guess so, but I'm fine without it.
Yeah. Anyway.
It's in the revision history.
Oh, we've got the 2 capacitor problem, do we? I'm just seeing the 2 capacitor. Oh, no. Okay. No, they're not going into the 2 capacitor charge problem. No, it's where the half in the half CV squared comes from. Where does half the power magically vanish? Where does half the energy magically vanish to when you charge 2 capacitors? And let's not go there. Wow. Yep. All right. So be it. Did we ever follow up? Speaking of weird things like that, did we ever follow up with the veritasium? Does energy flow in the wire or outside the wire?
No, I don't think so.
No, we
I think
didn't.
I opted out, and then I think there was other stuff that came out, and I was like,
Okay, so I didn't mention
yeah.
the quantum electrodynamics possibility.
No, you didn't.
Okay, we'll have to. Here we go. I'll link. Here we go. Pontus Farmer. I will. Yeah, and.
So you're saying that?
Hang on. I will get you the link. Here, right, here it is. So I'll send you the link. Cool. There. Anyway, so yeah, right. Everyone thought this was settled and that Maxwell and Poynting rule. Okay, you can't question Maxwell and Poynting, right? Poynting's theorem says that energy flows in the fields. End of story. The end. Except if you don't care, right? Which is what Richard Feynman famously said. He said, look, if you don't want to worry about the details like that, I don't blame you. I'm sort of paraphrasing Richard Feynman, but that's basically what he said, is that, don't worry that it flows in the fields. Who cares? It's like, So yeah, that was in his official Feynman notes, right? So anyway, but if you look at it from a quantum electrodynamics point of view, now we'll link in a video to Hontus Farmer. That's actually her name, Hontus Farmer. And she's a quantum professor or something. She has to do with quantums, not quantum electrodynamics, but she does work in the quantum field, right? Quantum field, get it? I'm here all week. Jeez. Okay. I've got to pay that one for myself. Thank you very much. Anyway, basically, pat on the back. Yep. Anyway, she basically explains on the whiteboard how, according to quantum electrodynamics, no, sorry, but with 99.9% certainty, and 99.9% probability, the energy flows within the wire in the electrical bonds between the electrons. So that, if essentially quantum electrodynamics trumps Poynting and Maxwell in this respect, so to speak. If you believe quantum electrodynamics, and it's not necessarily proven, I don't think. So I can't speak authoritatively on this, obviously. I did try to read a couple of papers on it, and my head exploded. So, yeah. Not recommended. But no, anyway, she explains how, essentially, this is like Newton, right? Think of, Poynting and Maxwell as Newton's laws. This is, it's a bit more complicated than that. But Newton's laws, which people still use, right? You can still fly to the moon.
Sure. Yeah, like relativistic versus Newtonian physics, that
versus
sort of thing.
Newtonian physics. It's like that. You've got classical electrodynamics, which is Poynting and Maxwell, and then you've got quantum electrodynamics, which is the quantum world of that, which involves probabilities of, fields and things like that. And she explains how it actually mostly flows within the wire. And it's like, okay. Yeah. And that's all great. Of a sudden, when that was raised on the EV blog forum, all of the Poynting and Maxwell people who are so sure of themselves go, okay, their eyes start darting around, and then they go, let's just ignore that, because it's actually too hard. So I've been thinking about trying to get like an expert, a quantum electrodynamics expert on to see if they can verify that, to see if they verify that according to that theory, it actually trumps Poynting and energy. So for all you energy flows in the wires, goddammit, people, then you can quote electrodynamics, apparently. Quantum electrodynamics. Anyway, cool. It's fascinating. Yeah. So yeah, I don't know much, it's not so, because we're all taught, right? We're all taught Maxwell's and Poyntings, any if you go to university, you're taught Maxwell's and you're taught Poynting, right? And that's, and it's fine, right? I'm not saying Poynting's wrong. Nobody's saying Poynting's wrong. But if you want to
people say Poynting's wrong if you're pointing and laughing at something.
Right. But if you want to go to another higher level of not thinking, but another higher level of explanation, then apparently quantum electrodynamics trumps Poynting. So that it's a fascinating argument,
Yeah.
So
yeah.
Yeah.
Yeah, I mean, all this stuff comes down to like mental models. Feel like as well.
Oh,
Like
yeah. Oh,
there's all
totally.
these different.
Yeah.
Some of it is the
Yep.
actual like math behind it and like
Yep.
what is actually happening in the physical realm. But then I have very simplified views of everything that's happening
Oh,
here
same here because we're
because
we are practical engineers, right?
we're
So
solder jockeys.
yeah,
Like
exactly.
yeah.
Solder
I mean,
jockeys. Yeah,
what
exactly.
the hell does it matter if it's
Yeah,
flowing the wire? Did the light bulb
it
turn
doesn't
on?
matter.
This is what I said last time. It doesn't matter. Does the light bulb turn on? It did. Great. Awesome.
And
Like yeah.
I can explain that with capacitance between the wires. Why do I need anything more complicated than that?
Yeah.
Maybe
Right.
transformer coupling if you want to get fancy pantsy, or
Mhm.
maybe it's a dipole antenna if you want to get even more fancy pantsy, right? And,
Mhm.
and so it's anyway,
Yeah.
I also brought up somewhere that because I'm now obsessed with DC, with this question at DC, right? Because to me, that's the fundamental question is what happens at DC? Does energy actually flow in the wire at DC? And
Yeah.
and it's
Yeah.
easy to explain this thing at AC and transient and everything else because there's so many different models. There's transmission line models, there's capacitance models, there's inductive models, there's antenna models, and then the photon models, and there's all half a dozen different ways to look at the transient thing. But when you're talking about DC, right? Does the energy flow in the wire or does it flow in the field outside the wire? Yeah, you know, it gets a bit harder. But anyway, I was thinking that the problem here is that if you can come up, because people have tried to, people have physically built this thing, right? I mean, they haven't gone to the moon and back, right? Halfway to the moon and
Sure.
back, but they've
Right.
built
Right.
physical
Right.
things and they've hooked their oscilloscopes up to it and they've measured that, it travels there within the 1 on C seconds, right? Some energy flows there on.
Mhm.
So it works, right? You can prove that, but I don't believe there's any physical experimental way that you can prove or attempt to prove that energy flows in the fields at DC. If anyone can come up, well, because I think if you can physically build an experiment to test that, then you've proved quantum electrodynamics or not. Right? It's that it's almost like the fundamental thing. If you can come up with an experiment that proves that energy flows in the field at DC, no transients at all,
Yeah.
then
Yeah.
you've
Yeah.
then you've either proven or disproven quantum electrodynamics, and I think that's probably Nobel Prize winning stuff.
I mean, isn't it impossible to truly ever reach DC though? Like, because at some point it's turned on, so eventually, it has to get to steady state. So you have to it's like how you window it and stuff like that too.
Okay, so it's the time of the universe thing, right? Okay, well,
I mean,
yeah,
yeah, I guess I
I
don't know. Like,
switched it on, but that was 10 years ago. But it's still not DC because you don't know what happens in the future. I might switch it off in a year's time, and then hey, it's not DC
right, right,
anymore, is
right.
it? It's like
Yeah.
come on. Right,
The
but
switching rate is
that's what all the theorists, they just
yeah,
sit around thinking about this shit. You know,
10 to the minus
it's like
12 hertz.
because no, sorry, that's what the mathematicians sit around trying to prove, right? So if a mathematician was trying to do this, they would go, "Oh yeah, nothing's ever DC because you can't you can't know what's going to happen in the future. You may
Right,
switch it
right,
off,
right.
right? And therefore, it's not DC anymore. It's it's just like a 1 year cycle time.
That's right. Yeah, exactly.
It's nuts. Oh boy. But anyway, I think it adds a fascinating curveball. Are you sure we didn't talk about this previously? I kind of remember yapping on
I
about
don't
it.
remember anything about
No?
quantum theory stuff. So yeah.
Okay. Hmm.
I think you
Interesting.
brought up the Feynman stuff. I think you
Right.
brought up
Yeah.
Feynman
Okay.
talking
Right.
about
Yep.
like the simplification of it, and
Got it. Yep.
yeah,
Anyway, I think it's fascinating. So there you go.
yeah, definitely.
Yep. And I'm kind of biased because because I'm on the side of it. DC, damn it, it flows in the wire. Fight me, It's like, yep. Anyway, there you go.
See,
Quantum
folks, this is what
electrodynamics.
happens when there's no chips to be bought. All we can do is
Right,
sit
is bicker
around,
about.
bicker about
Yep.
inside or outside the wire, and then someone goes, "Wait, how are we going to be able to buy this much wire?"
Come on, so give it. Where does your flag fly? Inside the wire or outside the wire?
I've told you I don't.
You just don't
I
care.
think
You just
inside
don't.
the wire, but I literally haven't thought about this long enough.
Right.
Like I just Dave, I'm just trying to survive here, man.
You solder
Just trying to
jockey.
buy parts. I'm just solder jockey, man. Solder jockey, writing some code sometimes, making videos sometimes. Just trying to stay afloat, you know. I am back to the wellspring that is LCSC and buying more parts from the Chinese ecosystem, just because it's all I trust right now. It's really weird,
right?
Like how this has all gone down. Like first off, I'm just buying a lot of parts at once, just so I know. Like I'm gonna just buy a bunch of parts.
You're part of the problem. You're a hoarder.
I'm totally part of the problem. I said that last time. I know that, but I'm gonna, I'm committing. Basically, I'm going on a blind date with a component, and I'm saying, well, I guess we're married now. And for better or worse.
Because I've got 10,000. I've had 10,000
That's right.
kids with you, so I'm stuck.
4 reels of you. Yeah, exactly. Yeah. To have and hold until the next part shortage.
Boy. Yep.
Yeah. So I'm in. I'm looking at. Let's see. What is the latest winner of part of the week? John Aerosmith Tech.
What?
Yeah, that's the name of the company. That's the thing. I'm buying chips from like unknown companies from the Chinese ecosystem.
John Aerosmith. Is this a Chinese company? John Aerosmith. It's like when
John XI-AN. John.
Oh, okay.
I'm sure I'm saying it wrong. I apologize to everybody who speaks Mandarin or
that's Juan or something. Yeah. Anyway. Because I thought it just reminds me of every time I deal with someone in China. It's hello Tiffany, hello Jack.
Yeah, I mean I wish they didn't feel like they had to do that. But it's I know. Understandable why they do.
It's universal.
If everybody butchered my name all the time, I'd probably pick one as well.
Yeah. I guess.
Yeah. I feel bad that it's the people.
Yeah, Bruce. Hi, Bruce. When it's like,
yeah, it's fine. Anyways, yeah. So I mean, and it's interesting, like so sometimes you'll see parts that are pretty darn similar to other vendors. So like
right.
So I'm just trying to find.
Have you got a link to this? Have you got a link to this?
Sure.
Juan Aerosmith. Is it actually Aerosmith?
No, Did I say Aerosmith? Oh my god!
Well,
I thought I said Aerosemi. Sorry, I thought I said aerospace, but it was Aerosemi.
As in aero, not arrow.
Arrow, like AERO.
Right.
Arrow. Did I really say John Aerosmith?
Yep. That's what I heard. It's your Yankee accent.
Yeah.
Anyway, they make OpAmps. They make precision OpAmps. They make LED drivers. They make power management ICs.
Yeah, I mean, they're just like not quite Jelly Bean, but
right, Jelly Bean-ish. Let's have a look at their precision OpAmps, shall we?
I think a lot of these too are they're second sources for a lot of things, right? So like looking at
$140. Sorry.
I don't know what you're talking about here, but yes, $140.
Oh, I'm looking at a precision OpAmp for $140, which is cheap for a precision OpAmp, That's a chopper.
Which OpAmp?
It's a chopper. Okay, so they make. Okay, so this is right.
Get to the chopper.
Get to the chopper. It's the MT0762, and it's a rail-to-rail 6.6 meg jobby. And it's a chopper one, and where is it? 5.1 microvolts, typical. It's a bit.
Yeah, so it would be interesting. You've done OpAmp reviews before, and it'd be interesting to find a company like this. I think they're second sourcing. Maybe very similar designs. I don't want to make any assumptions here, but either finding the comparative part. But this is what happens a lot too. People talk about like, I sent my design overseas and it went through a cost down cycle. It's not like they're like, if you're working with a manufacturing engineer, they're not like designing it with discrete components. They're just finding stuff in the local ecosystem that's a lot cheaper.
Yeah, right.
And then validating that it's meeting all the specs that you have. It's like, okay. Exactly. And so there's been stuff there at some point. I've never had visibility into that space prior to sites like this. I could go on 21IC and stuff like that and try and do it, but now it's just gotten a lot easier. And like I said, they have stock, and that's really all they care about right now.
You're right.
Especially and I mean, I'll be honest, I've thought about it once or twice with like certain components, if I was putting intelligence in them and they were network connected, maybe I'd be a little bit more standoffish, right? I'd be like, oh, okay, well, trust but verify.
Right. So you're drawing the line at some obscure Chinese microcontroller, for example.
I'd say like security elements and things like that. I mean, I guess you could say I use expressive components as well, and I love those. But like,
Right.
yeah. Some of it's just kind of a feel thing. I
Hmm.
trust the engineers, but maybe not the not the PRC.
Right.
So but like chopper op amp, okay, boost converter, okay. I would be interested. One thing I was thinking about with like the boost converter,
Mm,
and like you look at what's like a boost converter, buck converter is, anyways, right? Like
mm,
they're very mature ideas at this point, right? You can have more and more complicated kind of like surrounding circuitry, but like you talked about when we were talking about switching converters the other day too. It's like basically there's a switch, there's like a pass switch, and then there's some logic around that, probably a feedback circuit and an op amp
mhm.
internally and a reference and all these things. And it's like, okay. And so if you know how to make all that stuff and it does it as it's supposed to, I don't really need a lot of bells and whistles for the things I'm doing. So
Yep.
like, okay, that's fine.
And as long as you can verify that the part, as long as you don't have to put a lot of effort
Exactly.
into verifying that the part is going to do the
Yeah.
job, and as long as you're not on like the bleeding edge of specs, because if you're on the bleeding,
Yeah.
like if you've got a precision op amp that I told you about here, right? This precision
Yeah.
chopper
Sure.
op amp, right? You're using that because you want like ultra low input offset voltage, right?
Hmm.
And
Yeah.
then things like this spread can matter, right? Even like you
Right.
buy
Exactly.
one
Yeah.
and you measure it and it's fine, right? Oh yeah, and then you
Yeah. This one
build
looked great.
10,000 of them and you find that
That's right.
10% of your units are out
Yeah.
because these have a bigger yield, a wider yield curve, right?
Hmm.
Than
Yep.
the analog devices part that you pay 10 times the price
Sure.
for, right?
That's right.
So,
Right. Exactly. And yeah, and sometimes you're paying for testing and
yep.
binning and all that other stuff too. And so it is rolling the dice. So like
Hmm,
I probably would not buy a precision op amp because of those kind of things you're talking about right now. Like,
right.
but I can validate if, I'm making a 3.3 volt to 12 volt
Yeah,
boost
yeah.
circuit.
Yeah,
I can
exactly.
measure if it's 12 volts
Yep.
or not, right? I could at least look at the noise coming off of it and
Yep.
see whether it's within bands. But like I said, the stuff I'm doing is pretty low stakes
Right.
and pretty low volume, to be honest, too.
Got it.
So
So you have to weigh it up for each case, because like
I think that's
sometimes
right.
you
Yeah.
just like, yeah, it doesn't matter. I don't care. This is a jelly bean op amp, right? This is a jelly
Yeah.
bean
Yeah.
application that I'm doing. It
Yeah.
doesn't like I can literally drop in almost anything, as long
That's
as it's
right. Yeah.
stable or something.
Well, and the pinout's the same and
Yeah,
stuff like, and like this is
exactly.
a 5-pin device, right? There is nothing fancy about this, right? There's a
Hmm.
feedback pin, there's an enable pin, there's a drive, there's a switch pin,
Yep.
there's an input pin,
Yep.
ground pin. Yeah. So like super simple type of thing. There's just, yeah, you need to make sure that works then.
But when you have to rely on the
Same thing.
performance, yeah, that's when you got to put your thinking cap on and
Yeah, I think that's a trust but verify type of thing, and see if it fits your risk profile, and much like you probably should be doing with a TI or an ADI as well, right? But it's
oh
maybe you're
yes,
just a
yes,
little bit
yeah, of
more.
course,
I'm a
yeah.
little bit more lulled into the data sheet, and
And you can't just because it's analog devices, you can't just trust them. You've got to go right
yeah,
deep down into the data sheet, and you've got to go, well,
yeah,
what is the production spread, right? Because
yeah,
they'll actually
right,
like a good data sheet will put like if the part's important enough, like they won't do this on a jelly bean part. Who cares that a jelly bean op amp what it does over temperature and manufacturing yield and stuff, right? No one cares, right? But on
yeah,
your precision parts, a good manufacturer will put in all those okay, they've actually tested 1,000 or 10,000 parts for you, and they actually put the histogrammic data. Histogrammic? Is that a word?
mm.
It is now.
It's histomagraphical.
Histomagraphical. That's even better. Histomagraphical data in the data sheet for you, right? So they've done all the production testing for you, right? And then you can feel more confident. But even then, you may not. But even then, I've worked at companies where go, no, that's not good enough. We're going to do it ourselves.
Yeah,
Thank you very much.
right,
You
right.
know.
Yep,
And
yep.
yeah, oh god, we have to test 100 chips or something. Have you ever done that?
That's right.
Have you ever tested like 100 chips for a
At Keithley, yeah, I mean,
application? Yeah, I
we
can
had
imagine.
like production jet test jigs and stuff like that. Some of
Yep.
the magic was the actual like matching of transistors, like actually setting up
Yeah,
beta
yeah,
pairs
right.
and stuff like that.
Match
So
transistors
yeah,
and then do you thermally couple them? Gone are the days of people thermally coupling. You put a little
nobody does that anymore.
Nice little, put them back to back.
Piece of heat shrink and
nice little blanket around them, and
snuggle those together.
Anyway, speaking of which, I've got a segue for that.
I figured you did.
Mike, of course,
Dave, we're getting our cred back here.
Yeah, my Keithley 2400 Shmoo source measure unit. Shmoo. Source measure unit. I was using it the other day. Like I was using it for precision measurements. And like I was going to like do some, like a whole bunch of measurements for this. So I was setting up like sort of like an automated little station to do, because I was going to do a whole bunch of measurements. So I'm setting it all up, and it works fine. Always cross-correlate your instruments if you're doing precision measurements like this, So sure. if you've got like in my case, I've got the Keithley 2400 Shmoo and the Keithley, I can't remember the bloody part number, but it's this Keithley 7.5 digit meter.
DMM 7510. I'm looking at it right now.
All right. Yep. There you go. Because I can't see it from here. It's a weird color. Oh God, it's the same background bloody color as the. Get your colors right on you. Oh no, it could be green. I just can't see it from here. Anyway, I won't go on that rant. And I already did and embarrassed myself, but that's all right. Yeah, so I'm using these, and I cross correlated the two, and they're all hunky dory, right? Everything's fine. So I started doing my measurements, and then I decided this was late at night, so I went home and I thought, I'll leave them on overnight, because these things, when you're doing precision measurements, you want your instruments to warm up and get nice and stable.
Toasty.
You don't want them to. Right. Yeah, right.
Got to get that LTZ 1000 at its primo
exactly.
temp. Nice.
It doesn't just heat up instantly.
It's not about the actual absolute temp. It's about the stability of that temp, folks.
Yes,
40C,
exactly.
No problem. Just keep it there.
Yep. just keep it there. That's it. So I left it on overnight. I came back the next morning and I did some. I did some more measurements. Everything was hunky dory. But I was sitting here. I was sitting on my computer, and then I'd hear this there was this beep beep. And I didn't know where the hell it was coming from. It happened a couple of times. And then all of a sudden I see out of the corner of my eye, the Keithley 2400 Shmoo reset itself. Right? The bastard reset itself. So I went, aha. And then I actually shot a video. I've put it in the Reddit. It's not released publicly. So if you want a behind the scenes video, you can actually see it, because I do a lot of, I do those sometimes. I do just for my supporters and stuff. So this was like a supporter video. I just uploaded, and I meant so I got the camera out, and I thought, this bastard's not going to work. It's the lab coat syndrome, right? It's the white coat syndrome. If I turn on my camera and start talking about the fault, it's never going to happen. It's never going to reappear. But sure enough, it did. It actually, Murphy was asleep, and it happened a couple of times, like half a dozen times, while I was talking about it right on camera, and you can see the thing fail and reset itself. So
what is it? Do you know?
That's the thing, right? So I took the lid off and left it running, and it hasn't failed again. Well, no, it failed once. I heard it fail once, and then so I left it 2 days or something, and it basically only failed once that I heard. So it's really annoying. So it's hard to troubleshoot those sort of things. But anyway, I uploaded the video, and fellow YouTuber Marco Reps actually. He saw the video, and he coincidentally had exactly the same fault, and he just fixed it. And he said, "Would you like a spoiler?" And I went, well, I've had it for 2 days and it's not failing. So yeah, all right. Because there's not, I can't troubleshoot this thing if it's not failing, right? I can't, I just can't set up probing and wait, a week for the damn thing to fail. And he said, it's the battery. It's the CMOS backup, the real-time clock backup battery.
Yeah.
And he said that he looked at the chip. It's a Dallas semiconductor chip. I can't remember the exact number. It's in the comments there. You can probably go have a look yourself. But he said that real-time clock chip, or that chip, that Dallas semiconductor chip, has a reset output, which will reset the CPU if the battery's a bit flaky, right? So I thought, that's got to be it. But of course, I came in this morning, I measured it, and it's not that. The battery is perfect, so Murphy's not going to cut me a break. But yeah, his one was apparently doing exactly the same thing, and it was the battery, but it's not on mine. So I don't know what the hell I'm going to do now. I guess I put the lid back on it, and I just leave it powered up for a week and see how many times it dies. I don't know. It's a pain in the ass. It's really annoying when you get a fault like this and you can't. I mean, this is my second one recently I just did a video on my Fluke scope meter that I got off eBay, right? And
Oh
it
yeah, yeah,
like,
yeah.
and it
You
was
did about
working.
that
I
too.
was shooting a video. Look what I scored on eBay for under $100. Isn't this brilliant? It's practically brand new. Gorgeous scope, right? And then while I was shooting the video, boom, and the CRT collapsed on it, right? And then for the life of me, it just wouldn't happen again. So I started doing some troubleshooting, and stuff like that. I resoldered a few joints and did a few Hail Marys, and I put it back together, and it hasn't failed since. So I don't know, like, jeez,
Maybe you got the touch, man.
Oh,
Is this the combi scope? Is that right?
This
Or
is the
something
Fluke
else?
Combi Scope. Yep.
Yeah,
Fluke
yeah,
Combi
combi
Scope.
scope.
I've also got a video on the second channel where I do some more further tests and inspections of it. Yeah, it just hasn't failed since, and I can't make the damn thing fail. And I bet you the same damn thing happens with the Keithley as well. I'll put it back together, it just won't fail anymore. And then I'm always going to be wondering, well, what the hell was it? And you can't troubleshoot something that's not failing, right? So frustrating. It always happens to me every time.
All right, I'm going to tell you. I actually know of I think I've relayed. I'm going to tag this as maybe when we just cut out this. We're going to see how this goes. Remember, I've told you about a failure where the guy like tried something for weeks and weeks and weeks, couldn't trigger it to fail. Do you remember me telling you that story?
No, I've told several stories like that, but I don't remember your one.
Yeah, several stories like that.
Yep.
So one of those stories is the Keithley 2400.
Oh, great. Okay. Do tell. Come on.
I mean, so what it ended up being is something you can look at.
Yeah.
Anyways, the issue ended up being tin whiskers. So not tin whiskers. Sorry.
Yeah. Right.
But basically,
Yeah.
they had switched out a power supply.
Yeah.
And it switched from the power connector had been coated in gold, and it either went to gold flash or it went to tin or something like that. But basically, there was an intermittent from the power supply up. So it has like a 24 volt power supply coming in offline, right? So yours is a 240 in to 24 volts or 120 for the US, and then 24 volt supply, and then that goes up to the board. But this would only happen every once in a while where the connector had been swapped out. They didn't know about it, and so they couldn't get this thing to fail because it would only happen when the corrosion would build up enough on that connector, and then you'd have intermittent connectivity, right? And then the other problem is when you go to troubleshoot it, you pull the connector off, and guess what? It wipes all the corrosion off too, and so you don't even see it. And then you plug it back in, and it's like, oh, everything's fine again for another month until the corrosion builds back up. So maybe it's that,
right? Maybe it's that. Guess what you get if you have a tin whisker and a corroded and a touch in a corroded contact.
That's a Yahtzee.
You get a point contact diode, right?
Oh.
It can act as a point contact diode.
Interesting.
Yeah, so you can get like obscure stuff.
I said tin whisker. I don't think it actually is tin whisker though. Right. I think it is just a corroded contact, but between the power supply and the connector. I have
tin whiskers, and I found them by careful inspection under times 20 magnification.
That's crazy.
And it's you get so desperate. And I found tin like on really small products, so you can do this, right? Like on a large board like this Keithley 2400, you can't inspect everything for tin whiskers, right? It's just like it's impossible. But I've had.
I mean, you're without a schematic too, right? You're basically probing blind.
Is there a service manual available for the 2400? I don't
remember ever seeing one. No, not a public one.
Okay, damn.
Yeah.
All right, that makes it even.
Talk to me like 10 years ago, Dave.
Right. Okay. Right. And you could have hooked.
It's been 10 years.
You could have hooked me up.
It's been more than 10 years.
Yeah, I think it's been more, mate.
Good Lord.
You're old. You're married with kids
man.
now in a house in the suburbs. Yeah.
Yeah. Yep. Totally different part of the country.
Yeah.
Yeah. Jesus.
But anyway, tin. For those who don't know, tin whiskers are they grow. It's a metallurgical crystalline. Right? Growth due to tin, and I still don't think from a physics point of view they understand tin whiskers. I don't think. But anyway, if you've got tin, they can mysteriously grow, and and tin's conductive, of course, right?
I thought it was related to unleaded solder though too. Isn't that right or no?
No.
Wasn't that part of the?
If it's got tin in it,
well, unleaded solder has tin and silver, so yeah, it does.
I think it can still do it in theory, but yeah, I don't know. But anyway, the tin grows, and they grow in these shafts, and they can bend over, and they can short out to the pin next to it. It's like these things actually grow on your board and short out. It's freaky. Go and search for photos of tin whiskers, and it's just like you'll just be stunned. Like, and this isn't the same thing as like a solder splash or something, right? This isn't that. Right. It's your solder's perfect, absolutely perfect, and it grows. These little shoots just come out, boom, and they actually grow out and they grow. I think people have even done time lapse of tin whisker growth.
Oh, that would be awesome
in the lab. Of course, like you wouldn't get that in, Right, I'm going to set up my time lapse camera on this board, and you've got you've got 0.000001% chance of it happening. It's but it's a real thing. I did
find a video here. So. I just posted it. Yeah, Goddard. Oh, NASA Goddard Center. Okay.
Right. Okay. Let's have a look. Yeah. Sorry, I have to watch this. Yeah, I do have.
It kind of looks like a. Those really lame fireworks where they're just like the smoke snakes that just kind of
the smoke
pile
snake.
out. It kind of looks like that. It looks like that. Or like elephant. What's his name? Mark Rober.
Oh,
did
tooth.
That,
yes. The elephant paste or no elephant.
Elephant toothpaste. That's it.
Elephant toothpaste. Right. I just watched it the other day with Sagan because he's watching Mark Rober now.
Oh, cool.
Yeah. So and they're very cool. Actually,
someday I want to grow up and to be like a big YouTuber like Mark Rober. Right, Dad?
Yeah, exactly.
Oh, man.
Oh, boy. Anyway, apparently in Sagan's class the other day, he told me that all the kids, because they were stuck inside, I don't know, it was raining or something, they were stuck inside. And so they were all giving like free, so they had free time or whatever. And and all the other kids in the class were actually Googling me. They were Googling my channel and stuff like that. So, anyway. Ironically, I did have a very comprehensive video on tin whiskers, a very comprehensive presentation that I filmed. I went to all the effort to film a comprehensive presentation on tin whiskers. It wasn't me, it was somebody else, and like an expert on tin whiskers giving the presentation. And they told me to take it down. So it's been removed.
Oh, it's in the vault.
So, yep.
It's too bad.
Yeah, because like it is technically like a paid. It was like a paid thing, right? Normally you have to pay to go to this course on tin whiskers. But I actually asked permission. I didn't just turn up and turn on my camera. I asked permission. Sure. Can I shoot this? And I'll upload an edited, oh yeah, sure. No problem. And then I did so.
About it, and they're like,
and did it, and then hell broke loose, Yeah. So sorry, you can't see the tin whiskers video, which is very fascinating. So there you go. Well, that's it. Our amp hour's up. We pissed it away talking about quantum electrodynamics and, I don't know, rocks.
Computer history and I don't know.
What the hell are we going to title this one?
I was thinking we were going to call this one, I wrote it down.
We can actually title it, what the hell are we going to title this one?
How about histogrammic or histomagraphical?
Histomagraphical, yes. Hey, well, you could put histogrammical or Histomagraphical. You can actually put the word or and put both words.
Yeah, no, that's what I meant. Yeah.
Right.
That's
okay.
What I meant.
Right. Yeah. It sounds fine. I just don't ask me how to spell it.
Right. Yeah. Don't ask me how to make art for it.
I'll just put in a bloody histogram, dude. Just put in like get a data sheet.
Don't tell me how to do my process. I'm an artiste. I'm an artiste. You saw the bubblegum tap shoes art.
Yeah, bubblegum tap shoes. That's the pinnacle. Dude, you should sell that as an NFT.
NFT.
Oh man,
bring it on.
Make millions.
You're gonna be rich. You're gonna fleece some suckers about shitty art. See you next week.
Catch you next time.